All right, thanks for attending today's webinar, How to Power Telecom Sites in Challenging Locations. This is a special joint webinar between SFC Energy and Morningstar. Our presenters today are Terrell Conchu, Product Specialist with SFC Energy, and Brad Burwald, Product Marketing Director with Morningstar. Let's go to the next slide, and before we start, I should mention or remind people to please download a copy of the presentation slide deck that we're using today from the handout section of the GoToWebinar interface. And as you view and listen to the presentation, please go ahead and type any questions that you have in the questions chat section of your GoToWebinar pane. Terrell and Brad will answer those questions at the end of the presentation. And lastly, I should mention that we are recording this broadcast and we will email you a link to the recording tomorrow. So if we go to the next slide, Terrell, you're up first. So please go ahead and take yourself off mute and go ahead with your presentation.
All right, can you hear me all right? Very good. All right, thanks so much for joining us today. Before we get started, I might talk a little bit about fuel cells in general. Some people may have heard it's currently not working.
No, we're trying to do it. Just ask you.
How many folks can we see today? We're having some issues joining, it looks like.
I see we have, looks like we have quite a few in attendance.
All right, sorry about that little hiccup on our end. So yes, fuel cells in general. Not unlike batteries, there are many different kinds of fuel cells. Some are made up of different materials, some use different fuels. Ours runs off of methanol, and it is a direct methanol fuel cell. The way it works, if we could go to the next slide, please. Perhaps I'll give a little bit about our company there. We are actually a German company headquartered out of close to Munich. We have lots of history of sales around the world. Started off in Germany. We came to Canada around 6-7 years ago, and we have established in the States as well. So the product does have a lot of history. Maybe we are roughly new in North America, but we have a lot of experience, and this product is well tested. Next slide, please. So the way our fuel cell works, like I mentioned, there's many kinds. The best way to visualize our product is actually as a smart automatic battery charger. We're going to hook our fuel cell directly up to the battery bank, and we are going to simply monitor those battery levels. If you'd give me a click there, Brad. So as the load draws a battery bank down, the fuel cell will observe its set points, and we'll try to keep the battery bank charged between these set points. If you give me a click there, Brad. So as we can see, as a load draws the battery bank down, the e-foil will hit its switch on set point. She would do a charge cycle, charge that battery bank up, load draws the battery bank down, and so on and so forth. The cycle will continue. Now, in great situations where the solar power is able to maintain the battery charge levels, the e-foil fuel cell actually sits back and does nothing. It'll just simply sit back and monitor the system. It'll only actually engage a charge cycle when it's needed. So that'll basically let us leverage solar power for when it's best. Things like in the summertime, in the springtime, when there's lots of sun. The e-foil will only ever really need to engage if there is periods of no solar where we're not able to maintain that battery bank voltage. And there are a lot of other situations too that would lend itself to not being able to keep that battery bank charged. So like periods of long weather, periods of smoke, periods of snow, perhaps the solar panels are covered in snow. If you're like us here in Canada, that's something we have to worry about. So next slide, please. We have a number of different kinds of fuel cells here at SFC Energy. The ones you see on the left here, that is our 3rd generation fuel cell. There are 3 types, a 42 watt unit, an 82 watt unit, and a 125 watt unit. The one in the middle is still a Gen 2 piece of equipment. That's a 500 watt unit. And then the piece on the right, that is an example of our new hydrogen fuel cell. They haven't quite hit market yet. We're still going through certifications, but that is going to be a big part of our offering in the future. We're very excited about that. Next slide, please. Something to keep in mind about the fuel cell in general is, like any power generating piece of equipment, like any mechanical piece of equipment, it does have a lifespan. So as the unit accumulates runtime hours, what we're seeing here is an example of the Pro 2800. That's the 125 watt unit. It'll start out of the box producing its 125 watts. And as it accumulates hours, we're going to see a derate of the power output. So maybe around that 6,000 hour span, we're going to only be putting around maybe 85, 90 watts at that point. So maybe for some folks, that's not a really big deal. Maybe your load is only around that 40 to 50 watt mark. So being at 85 to 90 means maybe we can keep running that fuel cell for 7,000 hours, 8,000 hours. We have seen some come back with 9,000, 10,000 hours, and they're still operational. We're then able to refurbish or replace that unit for you. Next slide, please, Brad. A little bit about methanol itself. It is an extremely energy dense material, far more dense than a battery, let's say. So part of the big benefit of our systems is we get to rely on our methanol fuel instead of a large battery bank. I'll get to that a little bit more in other slides, but essentially we get 1 kilowatt hour per just under a liter of methanol, which can be quite helpful. These units themselves are quite safe to use. You could take the cap off and push it over, it will not spill. It actually has to be coupled with the EFOY fuel cell fuel hose, and it has to be pumped out of the cartridge. So it is quite safe that way. We've actually never had a spillage outside of something going catastrophically wrong and someone puncturing a cartridge. And in terms of transportation, these are fully certified to transport via road, sea, helicopter, back of an RV, back of a skidoo. They're quite safe and rated to be transported in any particular way. Next one, please. A quick example about how far fuel will go with a methanol fuel cell. So just an example here, the load we've used is a 50 watt load, and on the left you'll see 2 of our 10 liter cartridges. This alone would get you around 18 days of runtime. And if you go to the far right side of the system, you'll see 4 of our 60 liter cartridges. Now with this on a 50 watt load, it could get you up to 220 days. That can be quite a lot of time. Maybe your particular application just needs you to get through winter. Perhaps you don't get any sun in the wintertime. We have seen that. Or there's conditions where there's ice buildup on panels. We see that a lot too. So in these cases, when we can outfit a great deal amount of fuel with a particular fuel cell installation, we can get you quite a lot of runtime. Now, if you increase that load or decrease that load, you can see these runtimes vary quite as I'm sure as you expect. More load, you get a little bit less runtime. Less load, you could potentially get more runtime. And then of course, if we incorporate solar into these numbers at all, you'll see the runtime go much, much higher. When we're able to leverage solar in almost any way, the system benefits greatly. Next slide, please, sir. And click away, please. So yeah, a quick example about Canada. One thing we like to say is solar availability here is great in the summertime, but in the winter, it's significantly less. Give me 2 clicks there, please, Brad. What we can see is, and one more, please, sir. Yeah, what we can see is it can be up to 1/4 to 30% of the amount of solar available in the wintertime as opposed to the summertime. So that can lead to a good use case for something to back up that solar system. Next slide, please, Brad. So some of the real drivers between to do a hybrid system with solar and fuel cell is you get more reliability. So if any reason there was an interruption in your solar power, or it's just not able to bring in as much power, you have that backup power, a built-in battery charger in your system. You're able to reduce the footprint of your system. So to say, with a solar-only system, perhaps that you have procedures that say you need to have 7 days of battery backup, like some of our customers do when they use solar only. That means you need to have a large array and quite a large battery bank as well, depending on the size of your load. So when you incorporate a fuel cell into the system, you're able to reduce that battery bank significantly, as well as reduce your solar array quite significantly as well. Because now, instead of sizing your array and your batteries for the worst parts of the year to get through, you can actually just size them for the better parts of the year, while your fuel cell covers the worst parts of the year. Next slide, please. So this is just a little bit of an example. Fort McKay is up near Fort McMurray, Alberta, which some of you folks may have heard of. It's where our oil sands are located. This is an example 60 watt system in Fort McKay. So you'll see a solar only setup on the left and an EFOY fuel cell system on the right. And generally, as you can see in the numbers here, a significantly lower number of batteries and less solar panels as well. And then we can get you a great deal of autonomy. Like the system on the right would give us over that year autonomy, whereas the system on the left, the one thing we see and we're able to make a use case against is if you have your battery bank and it fails in the wintertime, those batteries go into a deep discharge and you have to replace that entire bank in some cases. You do that a few times and you're going to pay for the cost of a fuel cell pretty dang quickly. So it's not too hard to make a good case for a use of fuel cell in a lot of solar only systems, especially if the load is very important. Like especially if it's a critical load, it cannot go down. It's a very good case to bring an EFOY fuel cell into the mix. Next slide, please. Here's a good example of the calculations that we would give you in any quote. If you came to us with a need, an application, we'll turn around a quote for you for our recommended system. But these are the numbers you'll see. And what we've done here is I've used a mountaintop site. So what we see in mountaintop sites is in the wintertime, I don't know if any of you folks ski, but you'll see something called rime ice buildup. And rime ice essentially is ice that sticks to anything, and it can collect, similar to hoarfrost, like a foot, up to a foot of ice coverage all over this. So it renders our solar essentially useless in the wintertime. So what we have here is you can see the months on that graph, January through December. We've zeroed out solar for January, February, March, and October, November, December. So essentially what this system is saying is it's running completely off the EFOY during those months. And then in the middle, in the months we can expect sunshine, solar is doing the bulk of the heavy lifting. So we can generally do a projection like this for any system we turn around for any application anyone might need. Next slide, please. Something we can also offer too is a remote monitoring platform. The EFOY can communicate via two ways, either Modbus TCP, which is a great way a lot of our remote customers do that, or if you happen to be in an area that has an internet access or LTE cell coverage, you can access something called the EFOY cloud, and that's what this screenshot here is showing. This is the dashboard for the EFOY cloud. Essentially what it's going to show you is what that fuel cell is doing at any particular time, as well as the vital information you'd want to know about your system. Things like remaining fuel levels, battery bank voltage, any active errors, any active warnings, what the unit's been doing. There's a chart that shows charge cycles, ambient temperatures, basically, like I said, any relevant data you might want to know about the system, the EFOY cloud can display, which we've found that folks who are able to connect to an LTE network and then connect the EFOY to the cloud, they see a great deal of success using that platform, because you can program in things like warnings, things like notices, and just even check in on the system whenever you might need to. It can be a very useful tool in ensuring the success of your system. Next slide, please. Just a quick chat about the overview of some of our components we include in our systems. This here is one of our cabinet solutions, but we have multiple solutions. But you'll see the EFOY fuel cell, there's an LED touchscreen operating panel. We can incorporate our solar equipment and our power distribution equipment in there as well. Like you'll see our charge controller there in the back pan. You'll see our EFOY fuel manager that lets us connect to our fuel cartridges, the fuel cartridges themselves, and of course our battery bank, whatever we might be using. Typically up here in Canada, we use AGMs because we can't guarantee the internal temperature of these enclosures. They tend to be well maintained, but to use lithium ion, we need to be able to guarantee a good temperature. So yeah, please, next slide. Just a quick overview of what kind of solutions we offer, from smaller cabinets to larger cabinets, to mobile Pro Energy Box solutions, and to trailer solutions as well, and then to fully built out C-cans, which we've started doing recently. These are highly customizable, where we can put quite a large load, like 1 kilowatt to 2 kilowatts perhaps. We can outfit this C-can to provide a lot of methanol, a lot of system autonomy, and a lot of power. Next slide, please. Go into a few use cases for some of our energy solutions. This type of Pro Energy Box was actually installed in a pre-existing radio network for a forestry trunk road. So a lot of loggers, logging trucks, they use a radio network to be able to call out to each other as they do their pickups and drop-offs. I've actually been ran off the road by some of these logging trucks on these very roads. They don't mess around up there, but they use this system to power this radio network. So this is an example, 80-watt load. The winter temperatures are frigid, down to -40. These areas, as you can imagine, being on logging roads, are highly treed. So in the wintertime, solar can be very challenging. So this solution in particular here will back up that solar in the wintertime when it's not providing very much power. Next one, please. This guy here is one of our cabinet solutions actually installed in a C-can. You can just see the edge of the cabinet there with a solar array and the communications on top. Great application. Sometimes when a customer is able to deploy a small C-can or shelter like this, we just see the system a lot easier to control. All our systems are weather rated, but things like this can go a long way in just having the system see more success, more chances for working its best case. Next slide, please. Lots of radio repeaters, as you can see on some of these slides. This is a 75 to 90 watt application. Again, frigid winters, high winds. It's all stuff that we can design our systems to accommodate. This particular solution was a fixed solar. We were able to get a nice large solar array at a good angle. So this one was able to be quite successful. Next slide, please. This one here is a great example. These systems have been installed and running successfully for many years now. This is a good example of the rime ice I was talking about earlier for maybe some of you who are unfamiliar with these systems. The picture in the top right, this is an example of the rime ice buildup. These enclosures that the customer supplied, they actually install our loose EFOY equipment inside it. Like as you can see in the bottom right picture, that one 500 watt EFOY is rack mounted, and then the rest of their distribution equipment and stuff is mounted in the rack as well. But yeah, these systems have been running quite well, and we are able to accommodate things like rack mount or even just installing loose equipment into temperature controlled enclosures just like this one here. Next slide, please. And then yeah, another quick example about the Pro Shelter. Great application for remote and high wattage applications where we need to put multiple fuel cells into a single enclosure. This particular one was up to 1 kilowatt, and yeah, was installed somewhere very far north. And in this particular solution, we can put multiple of the 2800 or multiple of the 12,000 solutions. So you're going to get, yeah, like I said, that 1 to 2 kilowatt range is quite achievable on these ones. We've had some folks equip wind turbines to these as well. Next slide, please. So yeah, to kind of summarize up, the real value drivers in between using a EFOY fuel cell hybrid system with solar is you get the high power of solar. We can deploy multiple fuel cells to give you whatever kind of range you're looking for. There's a lot of reliability involved in our system since it is essentially a built-in battery charger. It is quite cost efficient in terms of operation. One of the points of pride of our systems is there's not a lot of maintenance requirements. Once it's installed successfully, everything's been sized well. You shouldn't have to visit site very often at all except to refuel your system. They're reliable, very eco-friendly. The amount of CO2 one of our small fuel cells kicks out is about the same amount as a person breathes. They are automatic. Once they are set into automatic mode, you can typically close up the system, turn away, and all is well. They're very, very quiet. You could have one operating on the desk beside you and you just hear a small hum. And yeah, we can remote monitor these systems with Modbus, TCP, or EFOY Cloud. And then you're going to get really long autonomy out of our system with that methanol backup. Something we convey to a lot of folks is all of our power is tied in that methanol. You don't have to worry about us having a smaller battery bank. The batteries for us is just a medium in which the power flows. If you need a lot of power or a long system autonomy, we'll try to outfit you with as much methanol as we can. And yeah, next slide, please. So yeah, to quickly wrap up, my name's Ty Conchu. Please take note of my contact info here. I'm happy to reach out, help out however we can. Happy to talk about how we can apply our technology. And thanks so much for listening.
Okay, thanks very much, Terrell. Really appreciate that. Good presentation, and really happy to be partnering with SFC today. So thanks
Likewise.
for all your effort. And yeah, I will go ahead and take over here and cover a little bit about Morningstar specifically. You know, the reason, first let me introduce myself. My name is Brad Berwald. I'm a product marketing director here at Morningstar, and I've been with the company for quite some time, over 20 years now. And one of our biggest areas of, I guess, advancement or growth in terms of how we sell and support our products has been with the system, integration of components. You know, the controllers that charge the batteries, of course, from the array, but we get asked for so many other things that they could do in the system. Manage external control of other charging. That's why we're talking here today with an excellent partner choice in SFC. We work for remote management and monitoring. We're often supporting a lot of unique loads in the system, control and automation. Data is a huge area of focus for us as IoT continues to grow year after year, and connectivity gets better in these remote regions, including from satellite now, quite economically. The scope of our expertise has expanded greatly, and we really want to talk about that and bring that to our customers and to the market through presentations like this, among other channels. So for that reason, yeah, these partnerships on our talks and our presentations is a great opportunity to do that. When I've supported a lot of what I would say is small to mid-sized telecom, we've just seen a huge demand for hybrid systems, so solar, but other backup capabilities, sometimes even grid backup, but also more interestingly, thermoelectric generators, of course, gasoline or diesel gensets, but more importantly, with fuel cells for the capacities of these systems that we're talking about, they're a much better match in terms of the power they put out. Generators, they don't really come in a small size. They kind of start at maybe a couple thousand watts and grow from there, and it's really hard to load them correctly. And when I discuss the needs of a lot of these telecom operators that have loads in this, say, 50 to 150 watt range, the fuel cell is an excellent fit because it has such scale and is able to deliver the power in a much more linear fashion. So with that, we see a lot of them being integrated with our systems. SFC has done a lot with Morningstar products as well, and we clearly mention their products and recommend them in a lot of these applications. So with that, what I'm going to talk about today is more specific on a single product, because while Morningstar has a broad array of products in our portfolio, the integration series is the one that really is the best fit for this type of application during our presentation today. And that is because it not only gets a lot of power and capability for the solar charge control, but also brings a lot of host of other system control features, which I want to talk a little bit more about. So we refer to it as, not just a charge controller or even an MPPT, but a fully integrated solar DC system controller, because it can do so much more, and that's what I'll be talking about. So first, to discuss a little bit about, from my view in the many years that I've worked in telecommunications, what a hybrid telecom system actually needs in terms of what customers are looking for. And I'd say first, the independent control of multiple loads. As many know, Morningstar's products generally have load control functionality on them, so that we don't want to disconnect the load, but we can if we need to in order to preserve the battery, especially in a solar-only system that may not have a backup charging source like a fuel cell. So that load needs to be able to be controlled. We need to measure the power. More often in telecom, we see the need for multiple loads, and that's because there's either multiple customers on a tower, like network A, network B, and network C are all on the same tower, and they all share power from that same system, so they're managed independently. Or it could be that the loads are prioritized. You have the service in the region or its primary transmission, but you also have maybe backup capabilities or monitoring or other more critical functions. So having multiple loads that are prioritized to be disconnected in series is really important. Also, of course, extensive battery chemistry compatibility. So that means charging the battery very well, charging a wide variety of batteries, and adopting support for a variety of chemistries. Of course, lead acid still quite a big workhorse in the system. We have newer options with, of course, AGM and others. We've done a lot of nickel cadmium. They're quite a pricey battery that have unique benefits. And then, of course, as everyone knows, lithium is dramatically taking over the market and getting new capabilities in terms of data, as well as, increasing some access to colder regions, but there are still some challenges there. So we provide a lot of that battery support through customization, through presets that can be saved, and of course, through direct communication with lithium batteries that have a BMS interface, usually in either Modbus or CAN bus format, and we provide that connectivity so we can read data such as state of charge, state of health, cycle count, and other communications right out of the battery directly. So, of course, system-wide state of charge determination is important. And you could be getting it digitally from the battery, but in the case that you're not, we also offer the option on the integration series products to calculate state of charge directly. So we put a very high precision shunt in the net positive leg of the battery you're using, and we're able to see everything that goes in and out of that system. So whether it's a load through our load control or possibly on the battery itself, like some system or parasitic loads, whether it's a charging source, obviously solar is accounted for through the controller, but maybe there's wind, a fuel cell, other inputs into the battery, everything can be measured. And then state of charge is calculated using an algorithm in the controller that we determine based on that power flow. Again, very accurate, highly efficient, and a secondary option if you do not have a communications enabled lithium battery. Support for multiple charging sources. Again, this goes without saying, as it's our main point of the discussion today, but bringing in the ability to manage those other sources so that they do so in harmony, that they're not in conflict, and that ideally that data is integrated together. We also provide auxiliary system control. So there's a lot of little needs in a system. Closing dry contacts, relays for load control, for alarms, to turn on a fan, to start a generator. It's an endless list, and we put a lot of power and capability, and in some cases scheduling, behind those auxiliary control systems. And it's flexible in the way it's designed. And then lastly, open protocol integration is incredibly important because we're all speaking the same language, and a lot of this industrial equipment, including the EFOI, which talks Modbus, just as the GenStar talks Modbus. And you'll find that being really common in automation and control systems, even in energy management systems. It's a grid tie protocol of choice as well for a lot of the sun-spec communications as well. So for that reason, getting everything all on the same page is a really important part of the system. And you'll also see with a lot of the solutions that we work on with our charge controllers and into a greater portion of the system, we're seeing deep integration with the charge controllers using those data interfaces, whether it's for remote management or sometimes to take control of the charger with another component in the system. So as Darrell mentioned, of course, these extended periods of cold and snow, which to be honest, I even got a new appreciation just watching his presentation. I thought we had some nice photos, like you could see on the side, there was some deep snow, but that Rima is something else in terms of, I can't see how anything is gonna operate covered in that for months. So really important topic we have today. So during that long duration where solar is not an option, these hybrid charging sources are extremely important. And as I mentioned, while we're starting to see more remote power being enabled by lithium through supplemental heating, it still has some progress to be made, but we do see that opening up opportunities and getting a wider temperature range. And while it seems counterintuitive to use energy from the battery to heat it in order to then allow it to charge, you basically take one step backward and then two steps forward when you do that, because you enable charging sooner so that you could take advantage of getting a higher level state of charge and using that solar energy. So with that, the DC system controller brings a lot of solutions to all of these small to medium-sized telecom needs that I just spoke about. So integrators, installers, and system designers that are looking for a product that is more than just a battery charger can get a lot of capability from the GenStar. It reduces total system footprint because, of course, you don't have this whole array of in-rail mounted equipment. You've got a very compact amount of control integrated using the ready blocks, which I'll be talking about shortly there on the right side of the product. And of course, with a massive amount of capacity, this controller can handle up to 5,000 watts of continuous power delivery. And we have the ability to oversize it up to 150%. And oversizing is extremely common now because solar is quite affordable. And as you can see in some of these regions where you may not be getting full sunny days every day, it allows you to put more solar on the controller that may be limited during the summer, but you'll be glad you had the extra capacity in the winter months when the days are shorter. So, but you'll see this overall footprint is, highly effective in terms of it putting it in a cabinet. The extra communications and cabling and power of a lot of those blocks that add those capabilities are all integrated in. So you're not running a lot of small gauge wire all over your cabinet. It reduces labor, of course, definitely improves reliability. You know, everyone's had a dangling wire in a cabinet. You know, where did this go? Wherever it was landed, it's not there now, and it causes problems. Loss of power, loss of communications, and most importantly, that those blocks can be expanded. It can grow for your needs. You can do a little more of measurement. You can do a little more of relay control, interface with the lithium battery or not. It's very flexible and can expand depending on your needs. So this is quite a diagram, but what it does is it basically just shows at the top, you've got the communications capabilities. You have that dry contact. As we go around clockwise, you can see contact signaling, scheduling, current measurement at the system for both individual sources or loads, as well as for the battery itself for state of charge across the entire system. Communicating with lithium batteries. We can provide generator start as well. All of the ready blocks, you know, go into the bottom there, and I'll be covering that on the next slide. Of course, fuel cell capabilities, which we just talked about. Even our inverters can interface with our products. If you need a little bit of AC alongside that DC system, there's an option for you, anywhere from 150 to 2,500 watts. And then, of course, the array. And then lastly, communications capabilities, wireless and beyond. So the reason it's important to show all that capability is we've always been supporting these types of applications at Morningstar. We've done it a little more piecemeal and supported our customers on putting together an integration package. So you can see here, our flagship product, the TriStar MPPT, along with the meter hub, gave it expansive capabilities for adding external load control using a TriStar PWM. Our relay driver, a favorite tool called the Swiss Army knife of solar off-grid because of all of its capability and configuration. We have our communications interface. Ethernet was more often an accessory. Now you'll find it as likely standard on most, if not all of our products coming out. And then you had to, of course, add BMSs and battery monitors externally. And they were never as good as you wanted them to be. They cost more. They were a little bit complex. They didn't talk to the charge controller. And unfortunately, we saw too often dominated by the marine and boating market, which is not telecommunications and off-grid remote industrial power. So this brings a lot of that together into a single product with the GenStar. So the Ready Rail system, as I spoke about, is basically 3 components. You can put in each one of each. You can put in 3 of one. There's a lot of variety here. That's both power and comms. So the Ready BMS does full communications via RS45 or CAN bus using the port on the bottom there, and it allows you to talk to those batteries. And we have an ever-growing list of integrated battery partners that provide that communication. So we're very excited about that and would love to talk with you about your needs as well. The Ready Shunt gives the ability to measure power from 2 shunts. So 1 block gives you 2 shunts. So you might say, I want to measure my wind inputs. You could say I need a net shunt for the battery so that I can get that state of charge on my, my AGM lead acid batteries. You can even measure multiple channels. You could put in 2 of these and get 4 shunts. Very capable product. And then lastly, the Ready Relay provides the capability of driving up to 2 relays. And unlike the relay driver, which pulls power to ground for a relay that you bring, we actually have the integrators, cartridge style relays integrated directly into the product. And again, you get 2 per block. So that's control, signaling, switching, dry contacts, alarms, you name it. Okay, so moving on. Powerful battery configuration, that's an option here. We provide a lot of presets based on our past experience in this market and continue to always give a lot of choices there, including more often support for lithium iron phosphate. Customization, these are just a couple examples of your standard 4-stage charging, your absorption, your float. If you see at the bottom there, that installer setup, and you tweak that arrow there, you'll see a very extensive list, very granular capability to provide all kinds of control for a system battery that you can save and then reutilize later in future systems. So it's like a lot of things. We give you the quick and easy, or we give you the advanced if you want to dive deep. The BMS integration is of course there as well. and then we give you those advanced settings, accounting for temperature, accounting for, of course, charging temperature, as well as being careful of those low temperatures when you're dealing with lithium. So also bringing these advanced data communications into the system is important, because that is something that we're often interfacing with a lot of site equipment. And I spoke about it Modbus, but we're also enabling SNMP that was previously only in the EMC is now standard in the GenStar. For those of you following this product, this is one of the many updates we've released. It is a living, growing product. SNMP has just become available, and the latest firmware you'll find on our website enables that function. Just update it and it's there. And that is a great option, because these new features are coming all the time. And that gives you your ability to read the solar energy system, but through a protocol that is designed for the telecommunications industry. And that's often read using network management software or NMSs. And we give a configuration file, you load it into your system, and then all your data just starts populating. And it's often used for managing bandwidth, like a switch or a router. You can see kilobits and megabits flowing across your network. So they're already in that world anyway. And now the solar data comes along with it in a single system, a single server, basically, which is really what everybody wants. So you can pull those. We use GET requests. It's customizable. We now support communities where you're able to actually provide groupings for your system. It's both more helpful in terms of organizing your systems by what they do and how they're clustered together with their peers in a massive deployment of hundreds of sites. That's really helpful. It also adds a degree of security, because it can be a custom set string that you make up. You can also actually access the operational data for the system through that as well, such as the state of charge. And then most importantly, we've also added a new feature. In addition to the community settings, we allow remote configuration changes using an SNMP set command. So that's not just a read, but a write. So a lot of capability there. Also, along with that, Bluetooth capability, something that was always part of the hardware from day one, but its support has grown as we've offered new features. You'll now find that we have Bluetooth in all of these products, so you can get local views of the dashboard and other data, and also those radios turn on or off, because it could be something you use daily. It could just be something you use only during the installation process. So when you leave the site, you can turn that off for security, close up the cabinet. And of course, Bluetooth wouldn't be anything without an app to go with it. So the MS Mobile app now supports, of course, the GenStar and soon many other future products as well. So you can do a lot of important things with this. You get a view of the system data. You can update firmware in the field over Bluetooth. This is something else that was added. And it's nice because if you have the MS app, the latest firmware for the GenStar comes with the app. So when you connect and you do that, that pairing with the GenStar, it also has the ability to push that new firmware. When the app updates automatically from either of the app stores, the new firmware comes with it. So big advantage, very easy to do, making sure all that recent capability that our engineering team has put together is in your hands quickly if you've already got a GenStar in the field. So, and then of course you'll see a lot of capabilities, both with the dashboard view, with the ability to see the blocks that are in the system to trigger certain conditions, such as enabling other charging sources or disabling them, and then of course firmware capabilities. Also, beyond the app, which just runs on your mobile device, we also have a built-in web page that is essentially a web app that is served directly out of the GenStar Ethernet connection. So this is not based in the cloud, this is local. It of course has great capabilities when it's on the internet, such as remote access, but it can actually be used locally without an internet gateway if you're interested. So what this does is this gives you even more functionality, custom set point capability. We have both a simple and a more advanced installer setup that's enabled using a password. And what I would show you at the bottom there is you can learn more about LiveView on our webpage with our product page that kind of goes over its top features. And I would invite you to click on the LiveView demo because it is a web app, and of course is also hosted on our website. And it's something you can try out today, even if you're not a GenStar owner yet. you could certainly give it a spin and look at the customization and the configuration options that you have in front of you. So definitely check that out. And what we're looking forward to is in the near future, we will be giving capabilities of using that web page so that you can actually customize your controller, save those settings to a configuration, and then be able to deploy those into actual GenStars in the field. So it's a really handy way to configure, what's essentially a complex system. A lot of customers that utilize our products, they don't just do one unique system. They do hundreds, sometimes thousands. So consistency and repeatability across those systems is really important, and that's why we've enabled features like that. There's advanced scheduling in there. You can go into all sorts of detail on a 7-day calendar, weekday, weekends, time of day, internet synchronized clock, always accurate, and a really handy way to add a time-based schedule to your functionality. Okay, that is my coverage of the DC integration of the GenStar. So that system control is really important, and that is the end of my presentation. So I'll now turn things over to Mark, who's going to take us through some Q&A, and hopefully we'll provide even more insight. So Mark, take it away.
Sure, great. Thanks, Ty, and thanks, Brad. Great presentation. We do have some questions that came in. For those of you who might have joined us late at the beginning of the broadcast, I mentioned that we will be sending out a link to a recording by email tomorrow. So just check your spam folder if you don't receive that in your inbox. We also had a number of questions about pricing. So we're going to get back to you individually by email on those questions, depending on what product, where you're located, and whether you're a personal consumer or an installer or reseller. So just wanted to take care of that. Let's see, we have a question here coming in from Guillermo, who asks, what happens to the carbon from the methanol fuel cell? So if you want to go ahead and take that, Ty.
Yeah, of course, absolutely. Yeah, there is a small amount of carbon inside methanol chemically. So when it goes through the chemical reaction in order to create power, it is a catalytic conversion, so a chemical reaction. Essentially, what comes out of the methanol fuel cell is warm air, water vapor, and a very small amount of carbon dioxide. As I touched on a little bit earlier, it's about the same amount of a CO2 as a person breathes. So yep, that does get exhausted into atmosphere, but it presents a significant reduction over competing technologies in that field.
Great, thanks for that question. Thanks for that answer. Let's see. All right, here's a interesting question coming in. Let's see. Question is, why do I need a battery bank? Can I run the load directly from the fuel cell?
Very common question, actually. We get that quite often. Unfortunately, no, the fuel cell is engineered, designed, and programmed to operate as a battery charger. So essentially, my first couple of slides kind of explain how the EFOY operates in between a series of set points. So basically, low charge and high charge and run times, to put really, really simply. So your EFOY is going to keep your battery at the level of charge that is optimal. And basically, yeah, we need to be able to hook up to a battery bank in order to do that. So we'll keep your battery bank charged up. You hook up your loads and distribution, things like that, to the battery bank. And on the fuel cell itself is only a connection point to that battery bank. There's no actual way to power a load directly off the fuel cell.
Okay, very good. Another question here for Ty. Can you support building automation and control networks protocol, otherwise known as BACnet? You mentioned support for Modbus, but the question here is, do you support BACnet?
I've heard of BACnet before, and I've used it with actually different products. Unfortunately, the EFOY is limited to Modbus TCP and then the cloud platform we talked about earlier. There are ways out there in which to translate information. Like, for example, we often pull information from the EFOY using SCADA packs from Schneider. We have pre-programmed SCADA packs for that. And then I know some folks can use the output from SCADA packs to translate a language into a usable language on their end. So it's not saying it can't be possible, but it wouldn't be possible directly with the EFOY.
Okay, very good. Here's a question about battery systems. And this is, I guess we can start with Ty and also go to Brad with this one. What do you support 12, 24, and 48 volt battery systems?
Absolutely, yeah. One quick thing to note too that popped in my head about the previous question. We are working on an API software to go with the cloud so that other operating systems can access the data points from the cloud. That is in the works. We don't have a firm date for it at this point, but a lot of customers are excited to use that. So sorry, back to battery bank questions. Yes, indeed, I didn't touch on that. The smaller Gen 3 fuel cells operate at 12 or 24 volts. The larger Pro 12,000, the 500 watt fuel cell, that operates at 24 or 48 volt.
And Brad, if you want to expand on that.
Yeah, in this case, I mean, we have a variety of products that work at all three voltages. Since I spoke about the GenStar specifically today, that product also does work at 12, 24, and 48. It's sometimes not as common to see the lower voltages supported on a controller of this size, especially from some of our competitors. But in this case, we do a variety of systems, large and small. Of course, your capacity goes down if your voltage goes down because it's limited by current. So you'd have to do those calculations. But yeah, we can basically take a pretty significantly sized array and charge any of those three batteries.
All right, very good. So here's a question about the exhaust from the fuel cell. Wondering what type of exhaust product discharge, and second question here related, are there any hazards associated with it if it's in a closed space? I think you touched upon this in an earlier related question, but Ty, if you want to talk a little bit about the exhaust and any hazards associated with it.
Absolutely, absolutely. Yeah, it's a common question. The exhausts are warm air, water vapor, and a very small amount of CO2, as we kind of touched on earlier. But as you can imagine, maybe just to expand a bit on that, the water vapor and freezing temperatures is mitigated. So we do, in all of our solutions, we offer a heat traced exhaust line so that we can maintain a proper temperature to exhaust that water vapor, even if the sub-zero temperature is outside. We've gone through a lot of iterations and making sure that the exhaust is as good as it can be to withstand these cold temperatures and things of that nature. But in terms of safety, you could have an EFOY fuel cell running beside you on the desk and it would be just fine. We're looking at getting these into classrooms. There's no combustion involved. It's all chemical reaction level. And like we touched on earlier, the CO2 is a very, very small amount. So yeah, perfectly safe to have beside you. And the exhaust is, it's a challenge to mitigate in certain environments, but we are fully on board for doing just that.
Okay, thank you for that question and answer. All right, let's see. All right, a question coming in from Greg here. Let's see. Are any solutions available that can generate fuel with excess solar power to reduce the need to refuel?
Interesting. In terms of methanol, no, maybe you're addressing hydrogen. There is a world in the future where we are looking at electrolyzers. So pretty much exactly what the question just frames. You can use excess solar power to run an electrolyzer that can pull hydrogen from water or just the atmosphere. So that solution does exist in the future. And it's with our hydrogen fuel cells, not the ones I talked about today. But in terms of generating methanol, of course, we can't do that. But one day, we'd like to see this product formulate in the future with our hydrogen fuel cells. Absolutely.
Just a quick interesting note on that. Some years ago, we did actually work with experimental system integration where they were doing that. Is they basically would look at the battery when the battery is completely full and solar energy would not be utilized. They were then switching, maybe through our auxiliary relay and diverting that energy to electrolysis. Again, not commercially practical at the time, but it was interesting to see that. And I know as you're going more into hydrogen, Ty, that'll be a cool area to watch.
Absolutely, yeah. Just take advantage of that power that's there. It only makes sense.
Yeah, because otherwise we open circuit the array. We have no more need if the battery's full, but this gives you the ability to put that to use. So.
Exactly. Store it for later when solar's not as good.
All right, fair enough. Okay, another question here that says, what is the response time for the EFOY fuel cell?
Great question. There are lots of different kinds of the fuel cells on the market, as I touched on earlier. Some of the larger generating power ones, they take quite a bit of time to ramp up to temperature before they can begin generating power. Ours is considered a cold fuel cell. It doesn't take near the amount of time to ramp up to generate power. So to start a charge cycle, depending on the state of the batteries, the state of the system, it could be as quick as 10 minutes, maybe 20. It all kind of depends on what the system currently looks like. But with our applications, delay between the kicking on typically isn't an issue because we have those set points. We're going to make sure that the switch on voltage to trigger a charge cycle is well before the battery is actually in trouble. So we're going to hit that switch on voltage. The EFOY takes its little bit of time to ramp up and do a charge cycle. We're going to do that well before the battery's in any kind of trouble. So power is readily available from the batteries, and the EFOY is going to make sure that it's keeping those batteries between those set points, or in other words, just optimally charged as well as we can.
Okay, very good. All right, here's a question for Brad coming in. Question is, do you need the ready relay to turn on the EFOY, or does the EFOY charger just charge it when needed on its own?
Yeah, that's a good question. In this case, I discussed this in detail with Ty and the team at SFC. Their product is fully automatic. And of course, I'll defer to you, Ty, after I answer so that you can talk a little bit more about that. But we do have a feature called external source control, and I touched on it a little bit, and it's often for getting generators started and things that kind of need that help that don't really have that intelligence, other, kind of simpler charging systems. In this case, the EFOY does not need us to tell it to turn on. It will work automatically in parallel, but that is a common assumption for a lot of other products that don't have the degree of control and sophistication that the EFOY fuel cells do.
Yeah, absolutely. That's correct, Brad. So to throw out some example numbers, essentially we like people to operate, the EFOY operates in automatic mode. So what that means is it's just going to sit back and watch the battery voltage. So to use some basic numbers, I said, maybe in a 12-volt system, our switch on voltage will be 12 volts, just to throw out there. So as the voltage is drawn down by the load, and maybe perhaps solar for whatever reason can't keep up at the time, once the battery voltage hits that 12 volts, the EFOY will initiate a charge cycle automatically, and it'll either hit two things. It'll either hit its maximum runtime setting, or it'll charge the batteries and turn off. So via that way, it is pretty much automatic. Yeah.
All right, we have a question here coming in about grounding. So the question is, are these systems positively or negatively grounded, or can you select either one? So I guess we can go ask Ty and Brad this question. So Ty, if you want to start out with that, and Brad, you can respond as well.
Sure, yeah, absolutely. That for us, that has been actually completely customer dependent. The system, we hook directly to the battery bank, and we have seen customers do either. Sometimes, yeah, we've seen both required, and since we're hooking just simply directly to the battery bank, it's completely up to any particular situation.
Yeah, I'd say the same. It's something that the product, the GenStar, and most of our products really are compatible with. It does not, create any problem for them. You do have to be careful a little bit in the system wiring to make sure that you don't have any kind of bust systems that may defeat that grounding. But in terms of if you need to configure it in telecom, such as the systems I've been supporting and speaking about today, they often come in either positive 24 volts or positive or negative 48 volt systems. And we've supported them both for a very long time. So yeah, that's really no problem.
Great. And just off the top of my head, I know Morningstar has a white paper on positive grounding and how that should be done. And off the top of my head, I'm trying to remember how to access that from our website. I think you go to our resources tab under white papers and access it, or search in our website, or if you just type in positive, I think that will come up. And if you can't find it, just give us a holler and we'll help you out with that, accessing that. All right, so that's a good question. Let's see, another question coming in here. Okay, let's see. Okay, so here's it's really a pricing question that I see Jeff is asking. So we'll get back to you. It looks pretty involved here, but it looks like a good question, but we'll have to get back to you by email to give you a more precise answer on that regarding pricing. All right, another question here. Where do I buy fuel for the fuel cells?
Great question. Yeah, absolutely. The answer is from us at SFC. We've gone through very stringent processes to make sure that our suppliers give us only the most pure grade of methanol. Since the power is produced via chemical reaction, it happens at the molecular level. If it is not of purity it needs to be, it can actually damage the internals of the fuel cell. So it can begin to change that reaction. It can tarnish the components. So from us is the short answer of where to get your methanol fuel supply. And we have a great deal of supply at all times, and we can distribute across North America. We have partners across the world just in case there's problems, and our customers across the world, of course, have to access it as well. So we do have a great deal of reliability behind our fuel supply.
Okay, thank you very much. We had a couple questions come in here regarding temperature. So one of the questions is, what is the coldest temperatures that the EFOY can handle and the GenStar MPPT can handle? And we're always, a lot of this presentation was based on some of the cold temperatures, but how about the warm temperatures? Can these solutions and systems work well in warm climates? And what would be the constraints of warm temperatures? So if we want to start with Ty, and then Brad, if you want to answer those questions.
Absolutely, yeah. So the EFOY Pro 2800, let's say, for example, our 125 watt unit, it's rated to -20 out of the box, just on the shelf. But what we'll do is we package these solutions, and some of those items you've seen in our slides. We typically rate our packaged solutions to -40, and we've tested them down to -45, -60. So essentially, we've put in a lot of effort to make sure they're going to operate at these low temperatures. And on the other side of the spectrum, we have deployments in Texas, let's say. So the units can operate in the extreme heat. In these solutions, we've actually deployed our solar panels to be a shade as well for the cabinet, just to help keep that temperature a bit more reasonable. But yeah, inside our package solutions, we have a ventilation system as well, just to make sure we're trying to draw out that hot air. The EFOYs, when they operate, they actually do, the fuel cell operates at about 75 to 80 degrees C. So that is pretty hot. And inside, like I said, we keep that ventilation engaged to make sure it doesn't get too hot. But it can definitely operate at high temperatures. At extreme high temperatures, you will just see the power output derate. But again, that's something we mitigate via package solutions or just via assistance if people are integrating on their own behalf.
Yeah, and I would say on the charge controllers across our portfolio, -40 to +60C has been a fairly easy temperature range to handle. As we've got into much larger products more recently, TriStar PPTs, and of course the GenStar being our largest, generally they can work to those high temperatures, but they will go through a derate generally around 40, 45C to 60C. They may not be able to handle as much of the full capacity as they're rated for to the battery. But the nice thing is that is determined by the controller, and it will automatically limit that current if the system was to get too hot. So in other words, it's not like if you go over that temperature, you're going to cause damage. It's just that it may start to clip and limit power a little bit earlier, but in the early morning or late evening times as well, that's something that it can probably run at full power. We've done a lot of work on this to provide those kind of derating charts and data from our engineering team, from our mechanical group. So they have information regarding input solar voltage, battery voltage, ambient temperature, other enclosure details, and we can help you with that if you need it.
All right, another question for you, Brad. Question is, can the GenStar MPPT provide remote monitoring for both the fuel cell and the solar system?
We both speak Modbus, as we've covered today. We do not necessarily get data from the fuel cell and bring it into the GenStar itself. We can give views of the array, the system, and anything that it's controlling. Our net shunt that does measure current will see and measure the current or any load power put in or brought out of the battery by the fuel cell. But in terms of the digital integration, we do not have that in our product. However, if we're both speaking Modbus, that is something that a third-party monitoring system could do. It could read data from both of our systems and then provide, you know, a collective view of everything at the site. You know, and that depends on the Modbus spec, what's available. We have one, and I'm sure SFC does for the EFOI as well. So Ty, you want to add to that? Because I know you have IoT capabilities, probably a little bit different view on the internals of the fuel cell.
Mostly what you touched on, yeah. With our cloud monitoring platform, we have access to display any relevant data you might want to see, and same via Modbus TCP. All the registers of that same data, anything relevant that key customers, people want to be able to monitor, it'll be available via Modbus TCP as well. So yeah, pretty much everything you just said there, Brad.
Okay, very good. Here's a question about transporting methanol. Question that Andrew is asking is it classed as hazardous, or basically how do I transport methanol? And he mentions UPS in here too. I guess he had a question about that.
It is classed as a hazardous substance. So, but the good news is a lot of common couriers are able to deliver it still. We ship out with a lot of common couriers, things like you just mentioned, UPS. It's typically not a problem. If someone was to be able to get their TDG certificate, you can transport it in your vehicle as well. It wouldn't be a big deal.
All right, terrific. We're getting, well, actually, we're just a little bit past the hour here, so we're going to wrap up. But I did see one other question here. Question is, would it be possible to disable the EFOI charger on a sunny day so it conserves the fuel when the charge controller starts charging well? And I guess we could go to Terrell with that question.
Great question. Really good question. I have a great answer for you. When the EFOI is in automatic mode, which it should always be essentially if it's monitoring a system, there's no need to worry about it saving fuel. If the solar is able to keep up the battery bank fully charged, the EFOI will simply sit back and do nothing. It will not accumulate runtime hours. It will not charge the system. It won't use any fuel. It'll just sit back and watch solar do its thing. Something I could throw out there as a caveat: if it is very, very cold out and the sun is also very, very good, like we get here in my home city of Calgary, the system might get cold, in which case the EFOI will detect that it's getting cold and it'll run a small antifreeze cycle. It uses very, very little methanol to be able to warm itself up. That is essentially the only thing you would see the EFOI doing in terms of using fuel if solar is able to keep the battery bank charged. Other than that, there's no need to manually engage it or disengage the EFOI to save fuel, because it'll simply not run when it's not required to.
All right.
Yeah, I would add to that, that we see a lot of applications. Yeah, again, a common question is you say, I don't want to burn fuel, I want to use solar first. But just as you know, Ty said, if it's set at the lower band of the battery, the charge controller is going to keep charging from solar and basically keep the battery high enough that you'll never see the fuel cell turn on, except in the exceptions that Ty mentioned. So they both have kind of their directions, and they'll both achieve that, and one will keep the other from running unless it absolutely has to. There's not really a need to disable, but you know, we've done this with a lot of other systems. It's interesting because there are some cases where genset controllers have run on a cycle that is not, you know, as sophisticated as this, and we have seen that occur in generators where they start in the early morning before the sun comes up, and you know, they wish that they could wait just a little bit longer, and we've worked on ways of delaying that. So if we see healthy sun, we'll keep that generator controller from running. But in this case, yeah, they will both do their jobs perfectly fine, and there's no need for us to control them or for them to control us.
All right.
Yeah, to touch on that a little bit more.
Oh, go ahead.
Touch on that a little bit more there, Mark. Yeah, for example, if an EFOI was to begin a charge cycle just as the sun was coming back out in the morning, they would simply both charge in tandem and top up that battery bank even quicker, and then the EFOI would disengage.
All right, now a follow-up question is, what is the life cycle of the fuel cell and what needs to be replaced?
Good question. Yeah, so I'll use the Pro 2800, the 125 watt unit, as an example again. We guarantee the unit for 6,000 hours, and typically we're going to try to size your system to use 500 hours a year. That is a target, 500 to 1,000 maybe. That's a target. Some systems based on solar availability will accumulate more. Some systems based on a low load may accumulate hours less. So we're going to try to give you a nice long runtime, nice long lifespan out of your system. Now, after that, if the power has derated just enough that it's no longer able to support and replace the load, you're going to want to look at either refurbishing or replacing your fuel cell. You can send it back to us. We will do a full diagnostic. We'll give you a quote to replace components that need to be replaced, but we can essentially take that power generating component and replace it with a new one. So essentially you will get those hours back. You'll be generating full power again. And that would be much less cost as to replace the whole unit, but we find oftentimes customers do want to replace the whole unit just to get that warranty period over again, and as well just peace of mind knowing that everything inside is new as well.
All right, very good. And let's just do one more and then we'll wrap things up. For Brad, what is the DC voltage high limit? We'll start with Brad first, and if Ty wants to respond.
High limit on the GenStar, well, there's two. I mean, one is it's 48 volts, so typically, I believe the power supply on the DC side can go, well into the 60s and much higher. I could check the specs to give you an absolute answer, but any 48 volt system, even extreme cold, is perfectly fine. On the solar side, the VOC is 200 volts. So you can go up to 200 volts open circuit, which generally means, several panels in series. We have quite a sophisticated string sizing tool on our website that allows you to choose from thousands of modules or enter your own specs. And then you can put in temperature data, battery voltage data, capacity of your array, and it's going to tell you basically if there's any kind of flags on that system in terms of cold temperature causing an overvoltage condition. So it really helps you to kind of constrain that system and make sure it's designed correctly based on average high temperature and record low temperature. Yeah, so that you don't get over that 200 volt VOC max.
All right, good enough. Anything you want to add at all, Ty?
Not really on my end. Essentially, what our unit will do is it kind of behaves differently than solar in this regard, because our unit will simply detect the battery bank voltage and it will charge. It'll distribute its charging current at that voltage and at whatever current it needs to. It charges similarly to a solar array, where it'll go through a bulk charge at high current and then an absorption time at lower current. So yeah, typically we can't quite answer the same as Brad did, but yeah, typically our unit is automatically charging the batteries, kind of like similarly.
Okay, and Brad, if you want to go ahead and advance to the last slide, the thank you slide. All right, there we go. You see the contact info for both Ty and Brad there. And just before I close down the webinar, I just want to remind people just to stay on after we close the webinar. You're going to have a tab open up in your internet browser that's just going to ask you a question about how would you rate the webinar, and then another question or another tab to come up to just ask if you have any questions or if you want to be contacted by either of us. So with that, thank you very much, Brad. Thank you very much, Ty, and thank you all for attending. We're going to close things out, and we'll see you next time. Take care.
Okay, thanks everyone.
Thanks very much.